The concept that we're discussing now with the help of this graphic is soil water potential. I mentioned previously that the soil water potential is a measurement of the energy that soil water contains. Free water, water exactly at the surface of the groundwater table, would have a total soil water potential of 0. As we go below the water table, water has a positive pushing force, and we would talk then about hydraulic pressure of the water. We are concerned when dealing with soil water energy and total soil water potential with this equation. This equation, the soil water potential equation, says that water is, or the total soil water potential, indicated here by the Greek letter psi sub t, stands for total soil water potential, is a function of a combination of the psi sub g, which is a gravitational potential, plus the psi sub m, which stands for matrix potential, and the psi sub o, which stands for the osmotic potential of the soil water. Water will move in the soil profile anytime there is a difference in the total soil water potential between two areas in that profile. That is to say that water can move laterally, water can move down and into the soil profile, or water can move up from stored subsoil moisture into a drier region of the soil above. What I'd like to do at this time is to look at each of these components of the total soil water potential equation and give you a little bit more information about what affects that specific component of this equation. The first part of the total soil water potential equation is the gravitational potential. Anytime we are above the level of the water table in the soil, the force of gravity will be exerting a positive pulling force down on that water which is being held in the pore spaces in the soil. So for all practical purposes, we have a positive pulling force of 1 gravitational potential on soil water that is being held in the pore spaces within the active root zone of absorption within our soil profile. Now this is going to be a positive pulling force that helps water move downward in the profile. But if we were looking at this the opposite way, if we were looking at the ability of soil to move up in the profile when it's higher moisture content below and drier above, then obviously the gravitational potential is a negative factor. By a negative factor, I mean it is a factor that would have to be overcome if water is going to be pulled up into a drier soil layer above one that contains a higher moisture content. Probably of most importance in this total soil water potential equation is the psi sub m, or the matrix potential. We've looked at in our conversation earlier that when soil particles come in contact with water, they exert a positive pulling force for that water. That's partially due to the adhesion between the soil particle and the water, and this is measured in terms of the soil's matrix potential. So the matrix potential is going to be something that is actually taking energy away from the soil water. It is a force which is restricting the movement of water through the pore spaces, because as we get closer to the surface of the soil particles, those particles will exert even a stronger pulling force for that soil water. So the matrix potential, the psi sub m value in this equation, in any soil at less than saturation, is going to be a negative number. That is to say, the potential energy of the water, as influenced by the matrix potential, will be negative energy. Negative meaning that we would have to exert a positive pulling or pushing force to get that water to move, or to get that water pulled away from those soil particles. Now as the soil gets drier, if we lose moisture content from the pore spaces in the soil, this matrix potential will become a larger negative number. And obviously if it becomes a larger negative number, that will also be reflected in our total soil water potential value, which is the sum of gravitational, matrix, and osmotic. Of these three factors, the gravitational, the matrix, and the osmotic, the matrix potential is the one that will have the greatest influence upon the total soil water potential at any given point in the soil profile. Another force that often comes into play in determining the total soil water potential is the psi sub O. which stands for the osmotic potential. The osmotic potential is a measurement that ions, or salts if you'd rather think of them as being salts, but once they dissociate into their ion form, they exert a positive pulling force for the water, somewhat similar to what the soil particles do. So the matrix potential is also going to be a negative value. It will be a direct or somewhat of an indirect measurement of the pulling force or attraction that ions, which of course come from dissolved salts, have in that total soil water potential equation. As the salt content of the soil is increased and we have more free ions in soil solution, this osmotic potential will become a larger negative number. Now when we start talking about the movement of water through the profile from an area of lower total soil water potential to an area of higher total soil water potential, this osmotic potential becomes even more important because we have to develop a certain osmotic potential inside of the root system of the plant to exert enough positive pulling force to get the water to move and separate from the soil particles or from the pore spaces around the soil particles and through the surface of the root system of the plant. So the total soil water potential equation will give us a value when we add up all of the effects of the gravitational, matrix, and osmotic. It will give us a value which will be a negative number at anything less than saturation. Water will move in the soil profile from an area of higher content to an area of lower content. Or another way of saying that is that water will move from an area where the total soil water potential value is a lower negative number, and it will move into an area where the total soil water potential is a higher negative number. So the psi sub t value in soils at less than saturation will be a negative number. The smaller the negative number, the higher the water content. The larger the negative number, the lower the water content being held in those soil pores. So if we relate it that way, water moves from an area of higher to lower concentration, or water moves from areas of a lower negative value for psi sub t towards an area of a higher negative value for psi sub t. Well, what are some values for psi sub t? How do we measure this? We can measure it in kilopascals, or we can measure it in bars or atmospheres of negative energy. On the next graphic, we will look at different soil textural classes, the amount of water being held over a range of matrix potential contents.